Hi guys, welcome back. In this video, we are going to see Class 10 NCERT Exemplar Chapter 2, Acid, Bases and Salts MCQs. There are total 30 MCQs are there in this chapter, but we are not going to discuss all these 30. We are going to discuss only 15. To make it short and sweet, let us discuss 1 to 15 MCQs in this video and remaining 15, from 16 to 30 in another video. I'll try to explain each and every MCQ in detail. Let's start learning. Number 1. What happens when a solution of an acid is mixed with a solution of base in test tube? So they're asking what will happen if you mix acid and base together. We know acid plus base gives rise to salt plus water, that is H2O. Now there are 4 options. You see, number 1, temperature of the solution increases. Number 2, temperature of the solution decreases. Number 3, the temperature of the solution remains the same. Number 4, salt formation takes place. Here we have identified that salt is produced. So blindly we can mark number 4. But here you can observe A, B, C, D options are there. A, 1 only. B, 1 and 3. C, 2 and 3. D, 1 and 4. Here one thing what we can do, anyhow in this D we have 4. So blindly we can mark this D. But let us try to understand this one. What is that one? Temperature of solution increases. You see guys, when acid and base, if we mix together, we'll get salt and water, and this equation is an exothermic reaction. What is meant by exothermic? Production of heat energy, right? So if chemical reaction is taking place, if heat energy is produced, then that equation is known as exothermic reaction equation. So automatically when salt is formed, temperature of the solution also increases. Hence 1 and 4 is the correct answer. So we need to mark this D. Next bit. An aqueous solution, I think so you know what meaning of that aqueous. If you mix water, in water, if you mix either acid or base or salt or something, now that entire solution will become aqueous. Okay, we have an aqueous solution, turns red litmus solution blue. So it is turning, this aqueous solution is turning red litmus to blue color. Excess addition of which of the following? So there are 4 options. In these 4, you need to add 1 such that that solution would reverse the change. Reverse the change in the sense that blue color litmus paper should turn red. Actually, let us try to understand which solution turns red to blue and blue to red. Try to remember B.R. Ambedkar. B.R. Ambedkar. B stands for blue, R stands for red, A stands for acid. So simply to say, if blue color litmus paper is turning red, that solution is acidic solution. Now what they are asking, red to blue. So if it is just quite opposite to that, if red to blue, if it is converting, definitely that is base. Now they are asking in question that solution, this aqueous solution is turning red to blue. Red to blue in the sense, definitely this solution is base. Now excess addition of what will change blue to red? Blue to red in the sense acid. Simply to say, we need to make that solution, base solution, as acidic solution. So you need to add excess amount of acid you need to add. Now try to observe 4 options: baking powder, lime, ammonium hydroxide, hydrochloric acid. Here baking powder is base, lime is base, ammonium hydroxide, which is ending with OH, that is also base, and here left with only 1 option, that is acid, hydrochloric acid. So D is correct option. Number 3, during the preparation of hydrogen chloride, guys, hydrogen chloride or hydrochloric acid both are same. On humid day, the gas is usually passed through the gut tube containing calcium chloride. The role of calcium chloride taken in the gut tube is 2. So why they will be passing that hydrogen chloride gas in presence of calcium chloride in the sense, you see, first of all, we need to get dry hydrogen chloride gas. Dry in the sense there should not be any water traces in that. So to remove water, we need to use that calcium chloride. Once you see absorb evolved gas, no, there is no option with water. Moisten the gas. You see what is meant by moisture? Amount of water, isn't it? So we need to get dry gas, not wet gas. Wet in the sense you need to add water, dry in the sense you need to remove water. So this is not the correct option. Absorb moisture from the gas. You see, absorb, it will absorb moisture in the sense amount of water from the gas. So if you are removing water, if something is absorbing water, it will become dry. Hence, this is correct option. Absorb Cl minus ions. No, there is no chance of absorbing H plus ions and Cl minus ions from HCl. So answer is C, absorb moisture from gas. Next, which of the following salts does not contain water of crystallization? What is meant by water of crystallization? You see, whatever salt you take, that salt will have some amount of water in it, but we will not represent it. For example, if it is copper sulfate, of course here they have mentioned, right, blue vitriol. Blue vitriol is also known as copper sulfate solution. That copper sulfate will be in blue color. And what is chemical formula of copper sulfate? We all will write CuSO4, but actually what is correct answer? CuSO4 dot 5H2O. So from this we can say salt has some amount of water in it. Now you see this baking soda, it has some chemical formula, washing soda, gypsum. You know how gypsum is produced? POP plus water, plaster of Paris plus water is gypsum, and chemical formula of gypsum is CaSO4 dot 2H2O. Then washing soda, Na2CO3 dot 10H2O. While coming to baking soda is nothing but sodium hydrogen carbonate, sodium bicarbonate. So NaHCO3, isn't it? Here in blue vitriol we have water, in washing soda we have water, in gypsum we have water, but in baking soda there is no water. So which of the following does not contain water of crystallization? Answer is B, baking soda. Next question, number 5. Sodium carbonate is a basic salt because it is salt off. You see, we know how salts are formed. Acid, if it is combining with base, we will get salt. Of course, we have two types of acids, strong acid, weak acid, two types of bases, strong base, weak base. Again, there are 4 combinations: strong acid plus strong base, strong acid plus weak base, weak acid plus strong base, weak acid plus weak base. Now, in case of strong acid plus strong base, we will get just salt. Strong acid plus weak base, we will get acidic salt. Weak acid plus strong base, we will get basic salt. Weak acid plus weak base, we will get normal salt. Now, what they are asking? Basic salt. Here we have basic salt, isn't it? Basic salt in the sense weak acid plus strong base. Is there option that you see weak acid and strong base? Strong base here we have, but strong acid not this. Weak acid, weak base not. Strong acid, weak base, strong acid, weak base. That is also not the correct answer. Weak acid plus strong base. Yeah, weak acid plus strong base. So D is correct option. You see, like that you can tell, or we have one equation also. How that sodium carbonate is formed? First of all, what is the chemical form of sodium carbonate? It is Na2CO3. How you got that Na2CO3? By combination of NaOH, sodium hydroxide plus H2CO3. What is H2CO3? That is carbonic acid. This sodium hydroxide is strong base, carbonic acid is weak base. You see, this is strong base and this is weak acid. Weak acid. So weak acid and strong base combines to form basic salt. Here we have basic salt. That is the answer you need to understand. Number 6. Calcium phosphate is present in tooth enamel. Its nature is. You see, on tooth we have one chemical called calcium phosphate. Is that acidic, basic, neutral, or amphoteric? They are asking. Answer quite simple. It is base. How? There are 2 things we can understand. Number 1, first of all, you see food what we are eating that contains acid, and the tooth enamel will be corroded. How? Acid should mix with some X such that we will get that corrosion. That X must be base, such that acid plus base gives rise to salt. Number 2. So from this condition we can say tooth enamel is base. Number 2. We will brush our teeth every day using toothpaste, isn't it? What is the nature of toothpaste? Of course it is base. You see, if our tooth enamel is acid, consider our tooth enamel is acid. If you add base, what happens? both will mix together to form salt and hydrogen gas. That is not happening because base can be added to base. Bases can be added to base such that this condition we can say the tooth enamel is base. So by taking these two conditions, we can say it is base. If you want, we can go with another condition, that is calcium phosphate. Chemical formula of calcium phosphate is Ca3PO4 taken twice. How this Ca3PO4 taken twice? You see, this is salt. This is basic salt something. How it is formed? It is formed by weak acid, that is phosphoric acid, PHOS, PHORIC, phosphoric acid, and one base, that is calcium hydroxide. Calcium hydroxide. You see, actually this is weak acid. Calcium hydroxide is strong base. Weak acid plus strong base. Here you can observe weak acid plus strong base. What we'll get? It is basic salt. Simply to say, this calcium phosphate is base. There are three conditions. We can say tooth enamel is base. Next, a sample of soil is mixed with water. So they took some soil from garden and they have mixed some water to it and allowed to settle. The clear supernatant solution turns the pH paper yellowish orange. Guys, you all have some idea about that pH paper. Start with 0 and it will end with 14. Here middle number, that is 7. 0 to 6, that is acid. 8 to 14, that is base. There are different color codings. Just if you observe 0 to 6, there will be colors like red, shades of red, that is yellow, orange, something like that. Shades of this will be there. They're asking it is yellowish orange. Whenever you find that yellow, orange, yellowish orange, reddish yellow, something, simply to say that is acid. Now this soil is acidic in nature. Which of the following would change the color of this pH paper greenish blue? Guys, this 7, that is green. 7 is green, and these all, I mean from 8 to 14, that shades will be blue in color. In pH, we need to remember only 3 colors: red, green, and blue. Whenever you see shades and patterns of red, that is acid. Shades of green, that is salt or neutral. Shades of blue, we can call it as base. Now simply to say that soil is acidic, right? Now which of the following would change color of pH to reddish blue? Simply to say they are asking, we need to add base, isn't it? Right. Let us try to see. Lemon juice, directly we can say that lemon juice is acidic in nature. Vinegar, what is vinegar? 5% of acetic acid, right? So that is also acid. Common salt, of course it is neutral, NaCl. NaCl is neutral. At last we have antacid, where antacid is used in indigestion, heartburn, right? So antacid is pure form of base made up of milk of magnesia. Now this would be the correct answer. Number 8. Which of the following gives the correct increasing order of acidic strength? Try to understand the question. Increasing order. So that increasing order of what? Acidic strength. So we need to write, for example, first, number 2, number 3, number 4. How many components are there? Those many components you need to write, and this last component should be acidic character, acidic or strong acid, something like that. And number 1 should be, I mean that acidic character should decrease. Here it should be weak acid, still weak acid. At last it should be neutral or weak acid, something like that. It should be. If you observe options, first they have given water, acetic acid, hydrochloric acid. You see they have asked increasing order. So that acidic strength should increase from one solution to another solution. First you see water, that is neutral, then acetic acid, that is weak acid, that is edible, right? We can eat. While making Chinese items, you can observe they will be using vinegar. Vinegar is nothing but 5 to 10% of acetic acid in water. Next, still strength increases, it will become hydrochloric acid, that is very strong acid. Now you see water, HCl, acetic acid, neutral, strong acid, weak acid. No, that is not the option. Acetic acid, weak acid, water is neutral, this is strong acid. No, that is not the correct order. Hydrochloric acid is strong acid, water is neutral, acetic acid is weak acid. No, what I told, first it should be neutral, then weak acid, and then strong acid. Neutral is water, strong acid is acetic acid, and weak acid is acetic acid, and strong acid is HCl. and water should be less than acetic acid, that should be less than HCl. And if you reverse the order, it should be like this: HCl should be greater than acetic acid, that is greater than water. But you see option A, that is the correct answer, where water is neutral, which is less than acetic acid, which is less than hydrochloric acid. 9. If a few drops of concentrated acid, acid spills over hand of a student, what should be done? Wash the hand with saline solution? No, not only washing with saline solution is not the perfect answer. Wash the hand immediately with plenty of water. Yeah, we need to use huge amount of water to remove that acid traces on skin, and apply a paste of sodium hydrogen carbonate. Sodium hydrogen carbonate, NaHCO3, we need to use, it seems. Let us another option also. Let us not conclude this. After washing with plenty of water, apply solution of sodium hydroxide. They are asking to apply NaOH, sodium hydroxide. Neutralize the acid with strong alkali. So acid is there, we need to neutralize it. I mean, we need to get some salt and water. How we'll neutralize it? By adding base. But only one thing you need to remember, guys: strong alkali. You all are aware of acid which is so corrosive in nature, isn't it? Maximum strong acids are corrosive in nature. Not only strong acids, but also strong bases, also corrosive in nature. You see that NaOH, which is strong base. Here they have given in D option strong alkali. What is meant by alkali? Bases which will be dissolving in water, nothing but alkali. Strong bases, strong alkali, both are same, which are so corrosive in nature. If you apply that strong base on skin, leads to more corrosive, right? So that we should not use NaOH, we should not use strong alkali, but we need to use this mild base, very weak base, that is NaHCO3. So answer is B. We need to wash, and then we need to add this one, NaHCO3, sodium hydrogen carbonate. Number 10. Yeah, they're asking again regarding that sodium hydrogen carbonate when added to acetic acid. Sodium hydrogen carbonate should be added to acetic acid. Evolves a gas. You see, sodium hydrogen carbonate, NaHCO3, which is added to acetic acid, CH3COOH, gives rise to what? First of all, we need to understand that is CH3COONA, which is nothing but sodium acetate. Sodium acetate. At the same time, it will evolve one gas, that is CO2. CO2 stands for carbon dioxide. Now you see, it turns lime water milky. Yes, of course. That is the test for carbon dioxide. It extinguishes a burning splinter. Yeah, of course. Oxygen is supporter of fire. Carbon dioxide is not supporter, so that it will extinguish. It dissolves in a solution of sodium hydroxide. Yes, CO2 will be dissolved in NaOH solution, definitely. And at last they have given it has pungent odor. No, there is no pungent odor for CO2. So answer will be 1, 2, 3. So if you find 1, 2, 3, here you can 1, 2, and 3. Answer is B. All these. It turns lime water milky. Next, it extinguishes burning splinter, and it dissolves in a solution of sodium hydroxide. Next, number 11. Common salt, besides being used in kitchen, can also be used the raw material for making what? So common salt, NaCl, is used to make what? In textbook we have seen that concept, and it is used for making a large number of variety of chemicals. For example, it is used to make sodium hydroxide and washing soda. These are ingredients. NaCl is raw material to make washing soda and baking soda. It is used to prepare HCl. How? HCl, and it is used to prepare hydrogen gas, chlorine gas, and that chlorine gas is used to prepare bleaching powder. So simply to say, this NaCl is used to make sodium hydroxide, washing soda, baking soda, HCl, hydrogen gas, chlorine gas, bleaching powder. Here you can observe washing soda, bleaching powder, baking soda. These all can be prepared using NaCl. And this slaked lime, no, slaked lime is not prepared using NaCl. So answer is 1, 2, 3. Here you can observe this 1, 3. So Here 1, 2, 3 is not there. If there is 1, 2, 3, blind you can keep that 1, 2, 3 here. NaCl is not directly used to make bleaching powder. NaCl is used to make chlorine gas. From chlorine gas we will get bleaching powder. So answer is 1, 3. So here A, that is sorry, not A, C, that is 1 and 3. If there is 1, 2, 3, we can keep it, but there is no 1, 2, 3 because bleaching powder is manufactured using chlorine which is manufactured by using NaCl. Next, one of the constituents of baking powder is sodium hydrogencarbonate and other constituentis. You see how we will get baking powder? You have to take baking soda which we will use in our house, in kitchen. Your mom will be using this baking soda to make idli, dosa, crispy pakoda, etc. And baking soda we need to add, to that baking soda we need to add some mild edible acid. Mild edible acid we need to add such that baking soda becomes baking powder. Baking powder, this baking powder they will use in bakeries to make cake, bun, etc. You see again baking powder, if it is added to water, automatically it will release some gas, that is CO2. That cake, bun, if you observe, that will be so fluffy because that carbon dioxide will be trapped inside. That is other concept. But you see what they are asking for that baking powder, sodium hydrogencarbonate, what is added? Mild acid is added. In that sulfuric acid is strong acid, acetic acid somewhat strong, and hydrochloric acid is also strong. But these two can be edible, tartaric acid and acetic acid. Answer is tartaric acid, because you can observe there will be some bitter taste, that is because of tartaric acid. 13. To protect tooth decay, we are advised to brush our teeth regularly. The nature of toothpaste. Already we have discussed that nature of toothpaste is basic. No need to go with the extra explanation for that. That is very straight question. Why toothpaste should be base? Because food items what we are eating, that is acidic in nature. We need to add base such that it will neutralize and it will prevent corrosion, tooth decay. Number 14. Which of the following statements is correct about an aqueous solution of an acid and a base? You see they are asking about pH, right? You all are aware of that pH scale. Starts from 0, ends 14, middle number is 7, and 0 to 6 is acid, 8 to 14 is base, and pH value. What is the 0? That pH value is 0. 1, like that pH value will be 1, 2, 3, 4. Now, you see, higher the pH, stronger the acid. You see, acid 0 to 6, isn't it? 0, 1, 2, these are strong acids. 4, 5, 6, these are weak acids. Now, if pH value is less, then it is known as strong acid. What they have given? pH value, higher the pH, stronger the acid. No. Higher the pH, weaker the acid. You see, higher the pH is weaker the acid. Yes. 4, 5, 6, you have to observe only from 0 to 6. I am talking 0 to 6. 4, 5, 6. Higher the pH value, then weaker the acid. Now, this is the correct. Lower the pH, stronger the base. Lower the pH. Now we have to observe 8 to 14. Here you see 8, 9, 10. These are all weak base. And 11, 12, 13, 14. These are all strong base. Now you see what they are asking. Lower the pH, stronger the base. You see, lower the pH. This is 8, 9, 10 is the lower number, which is weaker the base, not stronger the base. Wrong. Lower the pH, weaker the base. Yes, this is lower numbers. And base is weaker. This is correct. So answer will be 2 and 4. Can we find the 2 and 4 here? Yes, D, we can find 2 and 4. So that is the correct option. Next, pH of gastric juices released during digestion is, in our stomach, we have acid. Why acid is present in stomach? Quite simple, to digest. To digest food. Now, to digest food, acid should be somewhat strong. Not super strong, somewhat strong. Here you see less than 7. Less than 7 means maybe varies from 0 to 6, isn't it? In between 0 to 6. More than 7. More than 7 in the sense that is base. What I told, that gastric juices are acidic in nature. So this is not the correct answer. Equal to 7. If it is equal to 7, that is salt. But it should be acid. equal to 0. Equal to 0 in the sense it is very strong acid like HCl, H2SO4. Such type of strong acid is not present in our stomach. So this is also not the correct answer, and we are left with only one option, that is A, less than 7. So pH of that gastric juice is about 1.4 pH. So that is in between 0 and 6, answer is less than 7. So these are 15 MCQs we have discussed in this lecture, and in next video I'll upload where I'll be discussing 16 to 30 MCQs. Just subscribe to this channel to get continuous videos, and you will be learning all these videos. More informative videos I'll be uploading. At the same time, please share this video to your friends such that they too will learn along with you. So till then, bye. Have a nice day.